This one instead, the order was a little messed up. Anyway, so consider a doctor who administers two different treatments for patients with kidney stones depending on the size of the stones. Treatment A is surgical and treatment B is simple pills. Naturally, she prefers surgeries for people with more severe cases and larger stones. The following are the success rates of her treatments after a whole year. And we're given a table. So I think something very similar to this was covered in class as well. This is a question that I have extracted from your homework because I believed this was one of those that many people would struggle with, which is why I asked if you guys had attempted this homework yet or not. Anyway, we're going to take a detailed look at this. So let's see. You are given two different categories of stones. Stones can either be large or they can be small. And the size of these stones is what determines the treatment plan. Now, it's important to focus on this part over here. The size of the stones is determining the treatment plan. And essentially, the treatment plan is determining the outcome. So essentially, that kind of implies that the size of the stones is determining the outcome as well. The outcome in this case being the rate of success. It means कि जो stones का size है उसका भी impact है on the rate of success on whether the treatment is successful or not. And at the same time, the treatment selected also has an impact on whether the treatment is successful or not, on whether the patient makes a recovery. All right, anyway, let's observe. So for treatment A, for small stones, there is a 96% success rate based on whatever data was provided to us. For larger stones, the success rate is 73%. For treatment B, when it was done for smaller stones, the success rate was 87%, and for larger stones, the success rate was 68%. Now, putting everything else aside, let's look at this scenario. If a new patient comes to this doctor with kidney stones and this new patient does not know the size of their stones, so which treatment should be recommended to this patient? Would anyone like to contribute at this point? Okay, moving on. Anyway, so if a new patient comes in and the patient doesn't know कि kidney stones का size क्या है, it means that treatment A could be selected, but it also means that treatment B could just as well be selected. All right. Intuitively, we can see that overall treatment A ka, when you sum up these results, then the success rate of treatment A is lower than that of treatment B. For treatment A, the success rate overall is 79%. For treatment B, it is 82%. But I mean, this is one way of going about it. There are essentially two ways to answer this question, both of which will be considered correct. So this being the first, कि combined जो effect है वो treatment A का कम है as compared to treatment B. But when you look at this on an individual level, then treatment A performs better for small stones than treatment B. See, treatment A gives you a recovery rate of 96%, whereas treatment B gives a rate of 87%. So treatment A performs better on small stones. And at the same time, even for large stones, treatment A performs better than treatment B. So for large stones, treatment A performs 73% and treatment B की performance is 68%. But when you combine the results for small and large stones, we see that treatment B performs better than treatment A. The reason for reiterating this over and over again is that this is called the Simpson's paradox. अब इसमें होता क्या है exactly? This was covered in class as well. Sometimes an effect is observed across groups, but when you merge those groups, the trend vanishes. Or it can be the other way around as well. Sometimes what will happen is that a trend is visible, sorry, no trend is visible when you have subgroups, but when you combine those groups, a trend emerges. इस केस में जो ट्रेंड था इफेक्ट था वो रिवर्स हो गया as soon as both the groups were combined. And generally, the reason is that a confounding factor is involved. All right, so let's see. I'm not going to write down the answers to these. I will add them for your information later. And that's exactly what part B referred to. So for now, I am adding Simpson's paradox. That is the contradiction that we've observed in this data. All right. After this, you were asked to sketch a directed acyclic causal graph for the given problem, but I've added it already. Based on what was just discussed, the size of stones impacts recovery or the rate of success. The size of stones also impacts the treatment, and of course, the treatment is bound to impact the recovery or results. So, this is what our graph will look like. All right. Size has an impact on treatment and recovery. Treatment has an impact on recovery. And of course, recovery doesn't have an impact on anything. All right. Okay. At this point, we are asked if we can condition on any nodes in the graph to remove the confounders or contradictions. This question has been made quite simple for you, in fact, because you're trying to observe the effect of treatment on recovery. The only other factor involved is size. So essentially, if you condition on the size, then you can very easily find the impact of treatment on recovery. One other very important thing to notice in this particular graph is we're observing a structure that we have studied already. This is a fork. जिसमें size has an impact on treatment and size has an impact on recovery as well. And whenever you look at a fork structure in a causal directed acyclic graph, you always condition on B. In this case, B is size. So you always condition on it because when you condition on it, you're going to make treatment and recovery conditionally independent. And then with size out of the equation, you can observe the direct effect of treatment on recovery. So let's see. For this one, our answer would very simply be condition on size. And that will help you understand the effect of treatment on recovery. But that's not it. You are required to find this effect as well. You are required to to calculate the estimated conditioned treatment effect of both treatments. Let's leave that question for now and let's just do this calculation. I'm going to reshare my screen with you guys at this point because we will need to shift from here in order to do this calculation. Okay, can someone please verify that my screen is visible again? All right, perfect. So let's see. I've added this to OneNote just for the sake of our math. So what we are doing is, you know what? Let's add our graph over here as well. I think that might help. Okay, essentially you are conditioning on size. And what exactly does conditioning mean? You're fixing the value of size. And we know कि size की सिर्फ दो possible values हैं. Either it can be small or it can be large. All right, so what we're going to do is we are going to find the effect of treatment on recovery given that the size is small, and we're going to do the same given that the size is large. So let's get started. So first you would find First, let's fix the size to small. After this, let's fix the size to large. All right. So in this case, this is what you would be doing. The probability of our recovery, given that size is equal to, let's say I'm denoting small using the letter S right now, and then you're going to multiply that using the chain rule with the probability that the size is equal to small. I think that's exactly what we can add over here as well. And there are two things that I'm changing. The size is large instead of small now. So I'm denoting that using the letter S. Guys, just give me a second.